Um, Welcome everyone to this lecture. Today we are going to study a bit about industrial engineering. The topic which we have chosen to begin with is production systems, productivity, and cost of production. So I would have guessed that among all these four topics, productivity would have spiked your interest. What does it mean to be productive? So we'll get to that. But first, in any kind of industry, we need to broadly think in the basis of what are the inputs required to our whole system. So let's see. The first thing which you want to study is production. So what is a production? Production is some kind of input materials. Those input materials uh, could be like in case of, let's say, we want to prepare a duster. So for a duster, we would need the foam element and the wood element. And we would also need an adhesive. These are the raw materials required to make a small duster. Then let's say if we want to produce fat, that is also a production process. So let's see. Production is a set of processes or set of activities which we undertake to transform some kind of input through a process to an output. So that is the whole production idea. Input is taken, input of raw materials, of the machines which we are providing to the system, the labor which we are providing to the system, the man which we call, and then whatever techniques which we are using, which we call the method, that form part of the input. Then whatever process which we are choosing to transform the raw materials or to combine them, to apply different kind of processes to them, to apply different type of uh, combinations of them to produce some kind of output. And final, this is what is the end product, the output or the outcome, which we talk about in today's terminology. So let us talk about some kind of product and their outputs. Right. Now, each product also has an output which contains, let's say, we are talking about biscuits. So biscuits which we purchase from market, they are packed in a um, in some kind of packet or in some kind of aluminum um, foil or whatever that foil is or that packet is, and basically it is enclosing all the biscuits inside the whole biscuit pack. So that packaging is also part of the whole output which we have generated from the production process. And it is important for the biscuits to get transported from the raw materials through the process to the end user, end consumer. So it is our part as an industrial engineer, or it is part of industrial engineering that we minimize the waste coming out of the system and ensuring that whatever quality of goods which we want to deliver, quality of service which we want to deliver remains uh, uncompromised. So let's begin. So this is what production is, a broad definition that it is some input, process, and some output. So now what is a production system? Right. So production system means that we have a set of interconnected elements. So those elements are mainly again the same thing. There'd be the raw materials which we are using. We are having we basically connect the plan which we have of executing the whole production process, then whatever management which we have, and then eventually execution. So that is what production system it is. It is basically integrating all the things through a planning process, through a control process, and then through a execution process. So broadly speaking, as we were talking in production, we'll have some kind of inputs to our system. So those inputs are mainly the man required, that is the labor. Then we have uh, machines required in our whole production process. So let us take an example to make it interesting, right? Otherwise, it's just like a simple, boring thing. So let us take an example of a brake pad, which we are going to produce. So the input to a brake pad production facility would be the labor required for producing the brake pads, machines required. Now, what would be the machines? Machines would be like a hydraulic press machine. Then there would be a curing conveyor belt on which the brake pads and the material can be cured. And then we'll have some kind of what we say. There can be automatic weighing system and things like that. So they all form part of machines. Then we also need the method required, right? We also need to what techniques which we are going to use to basically uh, manufacture the brake pad. Then management. Then we transform the input through some transformation process to some valuable output to the consumer. There is also important part of input, the environment which we are providing. Environment. Nowadays, it is also part of the input which you are providing to the system. That what is the facility provided to the labor to manufacture the end product. So it comes part of the environment to the system which we are providing so that it is able to produce the desired output. Uh, so the transformation process in case of a brake pad production, it mainly consists of first of all, we'll be mixing all the raw materials together, which is mainly the fiber and the raisins which are fusing together, which are mixed together first. So there is a mixing process. Then there is a pressing process. So we press the fiber and the whole mixture against the brake pad or against the steel plate on which we are going to um, uh, basically make the brake pad off. So the steel plate has a lot of holes through which this resins and this whole material can seep through and form a great mixture and can form a great adhesive layer so that it is able to stick to the steel plate. The mixture is able to stick to the steel plate. So that is what we have in our transformation process. Then in every kind of process, we have to do some kind of modeling, or what we say, take feedback out of the system. This monitoring helps us in achieving what is the comparison between the actual output versus the desired output. This comparison helps us in initiating the next transformation process. So we will apply some adjustments here, and this completes our whole production system. The output includes the goods which we are producing and the services which we are delivering. So this is what a typical production system looks like. For a brake pad facility, like I told, it will have the inputs required. It will have raw materials like the resins and fibers. The steel plate is required, and basically or other machines are required, like CNC turning machine is required, hydraulic press are required, labor is required. All those things, they form part of the input. They have to be given to the system, without which our system cannot function properly. Management is also required. We want to manage the whole system. Then transformation process. So we transform all these input through the process which I explained to the desired output, or the actual output, which is we compare through at this stage when the process production, when the transformation process is complete. So now basically we move on to the idea of productivity. Okay, now we have made a system. Now, what defines the productivity of our system? So we will say that it is further categorized in three parts. One of the categorization is labor productivity. Labor productivity means what is the output achieved through the system in one complete day. For example, in one day, let's say I have produced this much output, X output or Y. So the output produced is the numerator, right? Because how much we have produced, that is what is required, divided by the labor hours. How much labor hour were given in producing the whole output in one day. So this is what labor productivity is. Example, while speaking, let's say if I am producing, my output is 100 brakes per day, or brake pads per day, and the labor hour which I'm putting is 10 labor hour. Let's say I have a very small factory and I have like two laborers working. So each labor works 5 hours, so they are completely, so they are working only, so they are basically total contribution is 2 into 5, that is 10. So this is 10 brake pads which we are producing. 10 brake pad per labor hour. So that's pretty good efficiency, right? This is like a very hypothetical system because brake pads they are very extensive technology and extensive devices. They require that curing process, mixing process. All they require a lot of operation of machines. So it's not a job for two laborers only to do. Maybe if the whole system is automated, maybe they'll be able to achieve. But what we have right here is like a very nice productive system. So this is labor productivity. Other kinds of productivity, if you want to guess. Labor productivity, there is material productivity, and that means whatever material which we are producing, how productive that is. And then we have machine productivity. Machine productivity is rather easy to guess. Machine productivity means that, okay, what is the capacity of the machine which we are using, and what is the actual output of that machine. That means that if let's say the pressing machine which I'm using to press the whole resin and fiber mixture on the steel plate, that pressing machine's capacity is 10 gigapascals, and I'm using 1 gigapascal of that. So that means 1 by 10, that would be the machine capacity for that or machine productivity of that particular uh, element. Then material productivity is already is also something which you can understand. For example, let us take an example of biscuits, right? So now when we are manufacturing biscuits, I used or basically the input to the system was some 10,000 packets to the whole factory, which was required for packaging the biscuits inside it. 10,000 packets we supplied. But eventually, the output was 9,990. 10 packets got discarded. There could be any reason. Because of that, the packets were, let's say, damaged, or let's say the package was of not desired quality. So in that case, we will say that case, the material productivity is 9,990 labor packets or packets of the biscuits divided by 10,000. So this is like some 0.999 productivity, which is very high. It's not like that in real life cases. Then we have um, cost of production. This is also an important aspect of any production process. So first categorization is on the basis that okay, what are the different costs we just want to add them. So we are not categorizing them. We are just thinking that okay, how these costs add up in any kind of factory. So first, let's say we are having uh, the direct costs which are involved, direct or prime costs. So these are the direct and prime costs. Direct cost means uh, they can be direct labor or direct material cost which is going to be used. Like in case of a brake pad, whatever mixture which we are using, um, that is to be put directly in the final product. That is direct material cost. Then we have direct labor cost, and whatever labor has to be present at the machine while manufacturing is happening. Then we have direct expenses. So direct expenses means that whatever energy is required, electricity. The electricity is essential part of producing the whole thing for this machine to operate. So that would be part of direct expenses. Next, we have indirect cost. So indirect costs also can be categorized in all the three things which I have labeled here. That would be indirect material. So what would be the indirect material used? Indirect material means that the material which is not part of the final product. So that would mean something like in case of manufacturing of, let's say, a steel plate. Let's say we are manufacturing a steel plate, then the fluid which is used to cool the tool, the cooling fluid of the tool, or we say cutting fluid, that particular fluid is not part of the direct material. It is an indirect material. And there are a lot of basically examples like that which are used in manufacturing of the product, but they're not part of the final product. And then we have indirect labor as well. The indirect labor is things like we have supervisors. So supervisors themselves not contributing at the shop floor, but they are very important in managing the planning of the whole day. So they are part of the indirect labor. Then there are indirect expenses as well. Indirect expenses can include things like the telephone bill of the factory or things like that. So all these are indirect costs. Next, then we talk about factory overhead. Factory overhead. So factory overhead means that it is basically all the costs which are used in maintaining the facility, right? We have to maintain the facility as well. We have to develop our facility as well. All this comes part of the factory overhead. So this basically becomes like the factory cost, right? So this factory cost is comprised of indirect or direct cost, indirect cost, and whatever miscellaneous things which may have. Okay, miscellaneous. Okay, now let's talk about total cost. Total cost, that would be our total cost is usually factory cost plus again whatever other cost which we can think about, right? So what are the other expenses which we are basically missing? So like rent of the factory. So that is also something which comes part of our the cost which is not direct, but it is included. Then we have internet infrastructure, which is required in today's days and age to maintain any new system or any uh, basically any factory. And that is what we are all the new transformation that is happening and is what is getting added in the total cost. So that is also what is part of the uh, planning process. Like whenever we initiate any process, we do not know what our final costs are going to be, what costs which we have to incur to get a competitive and advantage in a system. Like the thing which I told, internet infrastructure. It is not something which every factory needs, right? But if we have that particular facilities provided to the workers, then it definitely makes their uh, working easier. They are able to monitor their process much better way. The system is able to coordinate with each other. That is the basic thing. Earlier, we used to have telephone lines. So let's say there is a problem at one part of the assembly line, then that can become communicated to the other end by a phone call. But today we do not need that. We do not even need a phone call for that. We have modern systems which are able to monitor where is the breakdown happening, and it automatically stops the machine which is operating in some down channel system. So all those things which are happening, they automatically get added to the total cost of the system. Then we have cost. Selling cost. Selling cost means the total cost plus the profit which we want from our product, or which is basically which the market is assigning to the product. So this comes part of engineering economy. So I want to talk about little bit about the next video which we are going to do. So we are going to do break-even analysis in the next video. So break-even analysis is basically what it tells us basically कि at what point of production we tend to achieve or we will achieve the profitability of the whole system. So that is also an older concept. We earlier used to think that okay, if our production is going to increase, it is going to increase linearly. And when it is increasing linearly, and then we add the total cost to it. So because of linearly increasing demand, we'll get some kind of break-even point that at that point of time we'll achieve profitability. But we know okay, today the world is not like that. In fact, no kind of system operates in such a way where I described. Like if I were to say, okay, this is a system where increase revenue is increasing like that. So I don't think you would be able to tell one real life example where this happens, where the revenue is increasing just like that. Here the axes are different. Definitely, here we are saying, okay, we sell this product, sell this much products. Let's say N is the number of products which we are selling. So this is the selling cost, right? So, uh, right, this what is what happening. But this is taking the basic assumption that okay, we will be able to increase the number of items uh, in the given time. We'll increase them. But what if I start my items just above the break-even point? I'm profitable from day one. So that means that okay, I won't need break-even point at all. So that's what these ideas are. So thank you for joining.